we're ready to cam up the first part that we've downloaded, but the first thing we have to do is get the file into Fusion 360. And the way we're going to do that is we're going to go to the File menu, hit the drop down, and we're going to choose New Design from File. You're going to browse to wherever it is that you saved this file. In my case, I saved it to my Downloads file. I'm going to click on the file and choose Open. Once I do, you'll see the part opens up. When you open a part like this, it's always a good idea to expand out the document settings and make sure that your units are set to inches. The first thing I'd like to do with my file once I get it open is to go ahead and save it. So I'm going to choose to save the file. I'm going to add it to a directory on my Autodesk Cloud, and I'm going to call this CAMEX1. Go ahead and hit save. Now we're ready to start adding some toolpaths. I'm currently in the model environment, and to add the toolpaths, I need to switch from model to cam. So I'm going to hit the drop down and I'm going to choose cam. Now you'll see my toolbars all change to things related to the cam toolpaths. The first thing we have to do whenever we start a cam file is to go ahead and create a setup. To do that, I'm going to go ahead and click on the button right here called Setup. And when I do, you'll see a translucent yellow box that appears around my part, and you'll also see the work coordinate system that's associated with this cam setup. If we look at my dialog box, I want to make sure that my operation type is set to milling. And then I also want to pay attention to my ZYX to make sure that my Z is pointed up, my Y is facing away from me, and the X is going to the right. We could choose to move the work coordinate system around on our part, but in this case, we want this to be at the top dead center, so we're going to leave it right where it's at. Next, we're going to move over to the Stock tab. On the Stock tab, we're going to define the size of the stock that we're going to work with. Currently, my mode is set to a relative size box, and I want to do a fixed size box. I'm going to hit the drop down and choose Fixed Size Box. One thing you do want to pay attention to here is the round up to nearest. Many of you will have your round up to nearest set to 0.5 by default. I like to try to round up the value based on what I want to round it up to, not what Fusion thinks the default should be. If yours is going to show up as 0.5, what I'd like you to do is click in the box, set this to be 0, then right click in that same box and choose Make Default. What this will do is the next time you create a setup with a fixed size box option, the round up to nearest will be automatically set to 0 inches, allowing you to choose the rounding value that you'd like to see. Let's go and enter a width. For this part, we're going to enter a width of 6. We're going to enter a depth of 4 in the Y, and for the Z, we're going to enter 1.75. Now, if I look at this from the front, you'll see that some of the stock was added below the part, and some of the stock was added above the part. We don't need to face off this much stock. We'd rather have more stock below the part to be able to hold onto in the vise. So instead what we're going to do is we're going to change the model position. Note that the X, Y, and Z all have a model position control. The one that we're interested in changing is the Z model position. It's currently set to center. What I want to do is switch it to offset from top plus Z. When I do that, Fusion calculates the value to place in this offset dialog box so that the stock stays centered. We don't need a lot of stock above our part to be able to come back and face that off. So what I'd like you to do is enter an offset value of 0.010 or 10,000ths of an inch. You can go ahead and click OK, and that will complete our setup. I'm going to switch to a home view. And now you can kind of see the stock representation around our part. Should I click in a white space, our stock goes away. If I want to see what the stock looks like again, I can click on my setup 1 and it will make the stock representation appear. We're ready to start adding some toolpaths. What we're going to do on this part is we're going to face it, we're going to do an adaptive clearing operation, and we're going to do a 2D contour of the pocket on the top of the part. The first operation we're going to do is a facing operation. We'll find the facing operation under the 2D dropdown called Face. So we'll select that operation, and now we're on the Tool tab. First, we have to select the tool that we want to cut with. So I'm going to go ahead and choose the Select button. If you open it up and it looks like this, what you need to do is click on the Show Library Tree button. When you do that, this will reveal all the libraries that are on your computer with the default install of Fusion. For this part, we're going to find all of our tools in the Tutorial Inch folder. Once I'm in the tutorial inch folder, I want to select tool number 1, which is the 2-inch face mill, and I'll go ahead and click OK. You get a preview of what the tool is going to look like with the holder on, and you'll also note that all the values have been populated with the master feeds and speeds that were created when the tool was created in the library. Next, we're going to move to the Geometry tab. On the Geometry tab, we have to define the region that Fusion thinks needs to be faced. One of the mistakes that's often made by new users is to think that we have to specify a region by clicking on something in the model. What we really want to do in this file is face the stock, not the part itself. So I'm going to click on this X to throw that choice away. So everything is good on the Geometry tab. Let's move to the Heights tab. The two fields I want you to be most concerned with on this dialog are the top height and the bottom height. The top height defines where the cutter is going to start cutting material at, and the bottom height defines how deep it's going to go. In our example, it's going to start cutting from the stock top, and it's going to cut to the model top. This is exactly what we want. We want to face off any stock above the top of our model, so no changes need to be made on the Heights tab either. Let's move to the Passes tab. We can tell Fusion to make the stock just a little bit bigger than we made it. So to make sure that our facing tool grabs every last bit of stock that there is, enter a value of 0.25 inches. You'll also notice that there's a step over value. This is the amount that Fusion is going to make each time it makes a directional pass across the part. It's currently set to 1.9 inches, and you might remember that we selected a 2-inch diameter tool. Fusion did some smart choices in the background to set this to be 1.9 inches. To find out the choice that Fusion made, what I can do is right-click in the field and choose Edit Expression. When I do, you can see that the step over amount is being controlled by a formula. Don't worry if you don't completely understand this formula. You won't have to define this later. This is part of the default install of Fusion. And also note that if I simply wanted some other value, I type in whatever value I wanted to, and the formula that was set would then go away for this particular operation. We only have 0.10 of an inch of stock above our part, so we don't have to worry about doing multiple depths. Let's move on to the Linking tab. Remember, the linking is how the cutter enters the material, exits the material, and transitions between toolpath cuts. One of the only changes that I want to make for this facing operation is the extend before retract. Facing cutters often aren't plungeable or center cutting, and so what they will do is they will start off of the stock before they enter the stock. At the same time, when the cutter gets to the other end of the stock, when the center of the cutter gets over the edge of the stock, it'll lift off. If the machine head isn't perfectly trimmed, sometimes you'll see a wisp cut on the backside, and that's often not desirable. So what we can do is turn on Extend Before Retract, and what Fusion will do is it'll extend the toolpath by half the diameter of the cutter, ensuring that the cutter is off of the stock before it retracts. With those choices made, let's go ahead and click OK, and we should see a preview of a toolpath that looks something like this. This is the facing operation. It's always a good idea to verify our toolpaths and make sure that they're doing what we want them to do. So while the face one here is selected, I'm going to go ahead and click on the Simulate button. When I do, you can see a Simulate dialog box appears, giving me some different options. Without any stock on, I'd like to simulate this toolpath just to see what's going on. To do that, at the bottom of the screen is a play button. You also notice this slider. This will make your simulation go faster or slower or even reverse. We'll leave it at the default position. And we'll go ahead and click on play. And you'll see the cutter go through its motions on what it's going to do when it goes through and makes this toolpath. And you'll see it lift up. So right now that looks pretty good to me. What I'd also like to do is check it with the stock on. And to do that, I'm going to go ahead and turn on the stock checkbox. Now you can see a green box that envelops our part. I don't like this green color, and it doesn't show as much in my opinion. So under the material type, I'm going to hit the drop down and I'm going to choose wall paint. And I think this color gives some more contrast and is easier to look at. But now what I'd like to do is watch this tool cut again. So I'm going to go ahead and click on Start the Simulation. And this time as it goes, you can see it removing that 10,000ths of an inch skim as it goes through and removes the material. The simulation is finished, and I think I'm happy with those results. So let's go ahead and go to the next operation. The next thing we're going to do is an adaptive clearing operation. So from the 2D menu, hit the drop down, and we're going to select 2D adaptive clearing. I want to grab a tool again, so I'm going to click on the tool select button, and I'm going to scroll down until I find the tool library called Tutorial Inch. And inside the Tutorial Inch, I'm going to choose tool number 4, which is a 1/4 inch flat end mill. Choose tool number 4 and click OK. Again, note that all the feeds and speeds auto-populate based on what the tool was set to in the library. Let's move over to the Geometry tab. On the Geometry tab, Fusion wants to know what region of this part that we want to cut. In this case, we're just going to click on the pocket. This is the region that we're going to cut. So we'll just click on the floor face here, and you'll see it turn blue. That's the indication of the area that Fusion is going to cut when we click the OK button. On the Heights tab, the two fields that we're going to look at are going to be the top height and the bottom height again. The top height is currently from the stock top. In our case, we remove the stock top from the previous operation. Even though it's only 10,000ths of an inch, what we're going to do to get into good practice is on the from, we're going to click on the drop down and we're going to choose to go from the model top. That's where the cut is going to start to happen. For the bottom height, Fusion is saying it's going to go down to the contours that we selected, which is the floor. So the height is automatically being selected by the thing that we clicked on inside of Fusion. This is also associative. If in the future you change the depth of this pocket, when we go into CAM, we can regenerate the toolpath and it will automatically go to the proper depth. Let's move to the Passes tab. One of the key fields we'll change is the optimal load. This isn't called step over, instead it's called optimal load. What that means is the biggest cut currently that this tool would ever take would be 0.0625. It may be smaller though, as it whittles its way into these smaller corners. It may not take quite a 1/16 of an inch bite to make sure that it maintains a constant tool engagement angle. Let's change this formula by right-clicking in this field. I'm going to choose Edit Expression. Now yours may say tool diameter times 40%. I've changed mine to be 25%. What I'm going to do for this example is let's change it to be tool diameter times 20%. Once I get that made, go ahead and click the OK button. So we're going to 20% is going to be 0.02 inches. I'm going to choose OK, and now you'll see the optimal load is changed to a maximum value of 0.05. We can do this in one depth, so we don't need to turn on multiple depths, but we are going to mess with the stock to leave a little bit. Adaptive clearing removes material very quickly, but it doesn't often leave the best wall finish and sometimes the best floor finish. So for the radial stock to leave, what I want to do is I want to leave 10,000ths of an inch of radial stock material. And on the axial, we're going to cut directly down to the floor. So for the axial stock to leave, let's go ahead and set that value to be 0. On the linking tab, everything looks good here. Remember, this is how the cutter enters the material. So we can see under the ram type that the cutter is going to helix into the material at a 2-degree ramp angle. Go ahead and click OK, and you'll see the 2D adaptive toolpath appear. Again, it's always a good idea to simulate our toolpaths. So I'm going to click on my 2D adaptive, and I'm going to choose the simulate button. With no stock on, I'm going to hit the play button, and we can watch the tool cut. As the tool is cutting, to me, everything looks to be correct. It's always a good idea to wait until the end of the simulation. Again, this is where it's handy to be able to make the simulation go faster. I'm going to close that, and now I have my facing and adaptive operation complete. The third and final operation that we're going to do on this beginning part is we're going to do a contour pass around the walls to clean those up. From the 2D menu, select 2D contour, and we're going to use the same tool. So note that tool number 4, 1/4 inch flat, is already pre-selected. And if we see that, we don't have to go and select the tool and reselect the tool number 4. It's already selected for us. Instead, we can move right onto the Geometry tab. On the Geometry tab, we have to choose our contour selection. The contour selection that I'd like to make is the ring of geometry at the very base of the pocket. I'll go ahead and click on that, and you can see a blue line preview of what's going to be cut. On the heights, again, we're going to focus on the top height and the bottom height. For the top height, we're going to start at model top. And again, we're going to cut down to the selected contours for the Z height. So our Z depths are properly set. Let's move over to the passes. On the passes, one of the things that I would like to choose is to add a finishing overlap. If I let the tooltip appear, what this means is we don't want the tool to lead in and lead out at the exact same point. So we can add an additional value on that. For this 1/4 inch cutter, I'm going to set this value to be 0.05. Look at the linking tab, and as we go through the choices, everything should be okay in the linking tab, and we can go ahead and choose the OK button. And if we roll around and look, you can see that we get a 2D contour that goes around and cleans up the wall on our part. We're going to simulate all the operations together. To do that, I'm going to click on Setup 1, and I'm going to choose the Simulate button again. You can see now that when we have all 3 toolpaths on the screen at the same time, our screen kind of starts to become cluttered. This will get worse the more toolpaths that we add. So to clear things up a little bit, what I'd like to do is go to the Toolpaths tab, and under Mode, I'm going to change from All Toolpath to Tail. What will happen now is as the cutter cuts, a tail will follow the cutter around and then it will disappear. So that lets us see our toolpath, but not the entire toolpath all at once. Again, I'm going to turn the stock on. And now I'm ready to go ahead and simulate this operation. So I'll hit the play button. Now we'll see the facing operation go, and it faces the top of the stock off. So that part looks good. Now it'll switch to the 1/4 inch cutter, which is going to helix into the material, then start to radiate outwards, keeping a constant tool engagement angle using the 2D adaptive toolpath. It'll continue to remove the material until it's finished. Once the 2D adaptive toolpath is done, the 2D contour will come and clean those walls up. That concludes the top side of our part for this pocket. I'm going to go ahead and close my simulation window. It's a good idea to save the file. And that is your first 3 toolpaths.